Hey everyone, my name is Jackson Cheek, and this talk is going to be titled Awesome Android SDK Design. It's kind of a broad topic, so this will be focusing more on debug features and how you can achieve the same functionality that you get in your applications if you're designing a SDK, and then also how that's going to keep your product owners happy as well as all of your other stakeholders. So first, a little bit about me, or maybe a large picture. I am a mobile engineer at Compass, but I was recently here at Capital One, so see some fresh faces and old faces in the audience. And this is my first tech talk. Thank you. So let's go over the outline first of what we'll be talking about. I'll give an overview of some application debug features, stuff that you're all probably familiar with, but then maybe others that you're not, what kind of wins we get from them, and then we'll talk about debug features in SDKs, similar features that you have in your application, but then also kind of the catches and the hangups if you're designing a library as opposed to an app. Then we will talk about an example application or an example scenario. There's very little Pokemon related about this, but that's what the sentence is about. And I'll talk about a best practice or an approach to designing an SDK, and it's about leveraging modular SDK builders. So you would expose different functionality based on what builder you're using, and then they return a common implementation. And then we'll wrap it all up with a demo application that integrates the SDK. So, application debug features, we're all familiar with them. Probably the most common one that we all work with on a daily basis are your app pointing to like a QA or a staging environment. Some things that are nice about application debug features is that it improves testing and debugging. You can really speed up your development time by injecting different functionality into your application based on things that you've found to be hard to test, especially like, let's say if you're, for instance, you have a backend API team and they want to test a new endpoint, but maybe before they deploy it, they want you to point the application at their demo box, and in order to do that, you have to create a special build, and that's an ad hoc request. It's a lot of time. It consumes a lot of your daily processes, and if you can build a debug feature that changes the endpoint for the backend engineer, then you don't have to do all these one-off requests that take up a lot of time. It's also helpful for UAT. So what that means is your QA team or your product team, when they're giving sign-off on your JIRAs, they can quickly run through the acceptance criteria and the steps for testing, and then close out your tickets much faster. You also get help for your sales team and product owners, especially if you're selling to third parties. You can demo easily. Maybe there's a situation where someone is demoing the app and you're in an area with bad network connection, so you switch to a mock mode, so you guarantee that you're going to have 200s all the way throughout your app. But it comes with a cost. Definitely do not ship any of your debug features to prod. I think that goes without saying with your application. It's really simple. You can switch easily your code between your debug and your release build variants. Your code's cleanly separated, and you can guarantee that you're not going to prod. So let's look at some examples real quick. First one, like I talked about in the beginning, maybe you're switching between QA and prod or your staging environments. So you want some switch in like a debug view that can easily switch between your endpoints. Here's another one that's common that I like to use. If you're not at your computer and maybe you're not hooked up to Charles, perhaps you want some traffic HTTP network interceptor that you've injected into the app, like Chuck, for example. Shown here, you can get some really powerful debugging out of this. You see the headers, the response body, the request body, whatever HTTP code. You can easily report it to your API teams if there's an issue. It's really helpful. And it comes with like a single line addition to your OK HTTP builder. And yeah, it's really powerful. Here's some other simple ones, custom logger injections. In the first case, you see the regular Android log statement. It's a static call. It's only the Android logger. If you use something that conforms to a standard logger interface, you can get no up in release, the logger in debug, and then like system out in test maybe. This is a really powerful one, mock web server. OKHTTP has, or Square rather, has this open source library that's really helpful if you want to do mocking. It's quick setup, and you can immediately start hosting your mock web server on your device and not be reliant on any kind of live endpoints. That goes.
Is that on Android?
Yeah, that's on Android.
That's like a loopback, basically, without network connection.
Yeah. Let's save the question at the end, and then I'll loop back to it for you. So that continues on using dispatchers with mock web server. You can start stubbing happy paths. In this scenario, there's just a simple body and a response that I'm just sending back every time, no matter what endpoint I'm pointing to. That also helps for stubbing sad paths, and then this becomes really beneficial for UI testing because you're no longer reliant on a live endpoint, and you can just point at a mock server and get reproducible results every time, something that Don mentioned earlier in his keynote. Speeding along, maybe you want to do some localization changes, test your UI views, see if there's any differences in the languages that you're presenting. Maybe you're missing a string, so everything is in Spanish, except one string that you missed and wasn't translated, and then it would look weird, right? So you could test quickly with both. Deep linking, if you wanted to do some fast traveling through your app, skipping like the login, the registration, or the ftux flow. It becomes really simple if you have this way to easily navigate your application without going through standard flows. I'm realizing I have a bunch more. It's a cool GIF I found online of a quick way to alternate your app resources. Perhaps you wanted to demo different themes. If you're doing a sales pitch, it was something I remember at Capital One, where there's a third-party library that we were building, and yeah, this was something similar that was built. So there's more simulating push notifications, inspecting analytics, bug reporting, whatever else you can think of you can build. You can separate it into your debug build variant, and you get a lot of extra features for development, testing, debugging, demoing, whatever. So what does this mean for you and your stakeholders? It means everyone gets to stay happy, party, whatever. You can be secure in knowing that your debug code and your release code are separated. So there's a catch. You never want testing and debug code to be shipped into production. I think that goes without saying, but we'll find later that there's a common approach that a lot of people use by using is-debuggable code switches using the build config. So if you had an application and this was your build Gradle dependency blocks, this is how you would include your library. You'd have like a no-op module in release and then your regular module in production or in debug. And that leads us to the question, what about SDKs? Because it's a little different when you're building, because what gets published is your release build variant. So in your release build variant, you don't want to have build config code switches that are switching on and off your debug features. I'll talk in a second about why that's risky, but we want to design a library with all the same awesome debug features that we talked about just now, but also have them included in our SDK. So there's a little bit of riskiness in shipping them turned off. We also want to make sure that we're secure and prevent any kind of testing code from going out with our shipped binary. we're going to look at some code samples now. So this code is available on my GitHub right now, and then I'll tweet out the slides later. Okay, so let's start with a simple SDK builder. It's going to return a implementation of our SDK. Right now it's really simple, and the build function returns an internal implementation of the SDK. Really simple. Let's say we want to add a logger function that we can use to inject some custom features on. Maybe the logger prepends the class name, so we no longer have to worry about like a tag. Okay. Now the implementation requires a logger on its constructor, and we realize, oh no, we are opening ourselves up to the possibility of a third-party client application that's going to consume this SDK, injecting their own logger, but maybe we don't want that feature exposed. Okay, so in order to fix that, let's add an isDebuggable code switch here. And if we are in a debug mode, we'll inject the logger. If we're in release, we'll just no op. So here's how that switch is built. It's just a simple if-else statement that looks at the build config, and then it's true if you're in debug, it's false if you're not. Okay, why is this risky? The code paths that we just saw here, you could strip them out with ProGuard optimizations. So that is like dependent on your release pipeline, including the correct ProGuard configuration to strip out everything. I know ProGuard can be simple for your like a basic application or a basic SDK, but I think the more complicated all of your dependencies become and all of your just code in general, like however modular you are, it could become more complicated, and you have to be really confident that the code is actually being stripped out. So that involves decompiling your APK, extracting all the binaries, double checking to make sure that everything is removed. That's a highly manual process, and there's a better approach. You don't have to do all the manual things that I just talked about. So you could, okay, this is like the pitch. It's a simple approach. You can leverage two different types of builders. I'm calling them modular SDK builders. The idea is you have a development builder that exposes a lot of functionality on via like public functions on the builder, and then a lockdown release version of the library, or sorry, the builder that only exposes what's exactly required for release. Right. You only want to publish the production artifact or the prod builder artifact, and then the development builder artifact would get only distributed via your internal development environments. So like if you had a demo application, that's where the dev builder would live. It would never go to public Maven. So here's a question. Do we still get all of our debug tooling features that we talked about for applications in SDKs? And I think the answer is pretty obvious that, yeah, we do. But it requires a little bit of upfront elbow grease with these SDK builders in order to achieve that functionality in a secure way. So here's my shoehorned Pokemon, and we'll talk about a scenario where we build an example application or example SDK and demo application. Let's say your product owners and user research team come back and decide that there's a business opportunity selling an SDK that returns a user profile. So like a picture, some information, your name, age, date of birth, whatever. In typical Jira fashion, let's define some acceptance criteria. So including the SDK, we want to have a demo application that integrates it. We want a lockdown version of this SDK that does only the release functionality. And then we also want a debug version of the demo app that includes all of our nice debug tooling that's going to be helpful for automated testing, manual testing, demoing, product sales, whatever. All right, so here is quick example of what we'll be building real fast. This is kind of like the storyboard, I guess, but whatever I could fit in GIF form. You have a client application, which is considered a demo app, and then the green is the SDK. It returns a name to the demo app, and then displays all the user information on screen. The important thing to note here is that the SDK has a UI component, and then when that button is clicked, let's see if this works. It's hard to tell. When the button is clicked, all of the UI work and like networking is all handed off to the SDK, and then it's returned back to the demo app. So we'll start simple. This is the public interface of the SDK that we'll build, and what it's going to achieve is, or implement rather, is this start flow function, which has a callback on it that the client app will provide, which all it's returning here, this result callback, is just a simple result monad that has like a on success or on failure type response. And yeah, let's look at the implementation now. It's real simple. The constructor takes an argument params. What that really is just a data class wrapper around all of the different arguments that we want included when we build the implementation. One of those, for instance, could be SDK session, which in this case is just a coroutine scope that launches the UI SDK, which is a base library, and then starts flow. Pretty simple. Okay, so that was the implementation. This is like an initial approach at a builder that we would release to the third party that would be public. It exposes a function params, and build then requires that object be not null, and then you get an implementation of your user profile SDK. That is really that's beneficial. That's exactly what we want. But let's say we want to start adding some debug features. So one way we could do that is by including additional public functions on our builder that take in whatever debug functionality that we want to inject in. So in this case, we have base URL. Base URL is the simple one. It's a way to modify our network endpoints. Region in this case is just country code. So the demo that I showed before, the GIF, it would just be users that are returned from different countries. Maybe you switch it to RU and you start getting Cyrillic names and see how your application performs. OKHUT Builder is a way to inject different network interceptors, like the chuck that I showed in an earlier example. So on and on and on and on and on. You have all these debug functionality that you're including on your builder, but you need to make sure now that the SDKs or the SDK builders are separated in a way that you're only including those public functions on your development side. So here's the design. Let's start with our demo application and one of our stakeholders, like a tester or other developers or product, whatever. Based on the build that we're going to create with the demo application, if it's like a prod flavor or one of our development flavors like mock or dev or debug, whatever you want to call it. Based on that, they use, in the dependencies of the application, we provide either the dev builder or the prod builder, and the dev builder has all of our debug features, and then the prod builder is just release. They both return a common implementation of the SDK, which is really nice because they both adhere to the same contract that we've already defined, the start flow, but the builder itself has injected all of the debug functionality that we want if we're in debug, and then separated if not. And then on top of that, since we all love modular code and incremental builds, the underlying base libraries can be whatever else we want. So the actual SDK builders and the actual user profile SDK modules can be really small. Everything else is handled in these, or the majority of the heavy lifting is in these base libraries. So here it all is again. Pretty simple design, and it's actually quite easy to implement. This is the source structure. It's a simple application, so it only has like 6 modules, but your projects could be much larger. Also, the comment or the note here that do not publish the dev artifact. Everything else can go up to your public Maven if you're shipping it to like a third party, but yeah, you wouldn't send it out.
So where are you archiving your dev artifacts?
Somewhere, like if you had an internal artifactory or something. But yeah, so let's see. Yeah, this approach isn't revolutionary. There are some existing examples that I'll demo or look at here. Here's popular memory leak detection library, Leak Canary. They've got a no op and release. And then I talked about Chuck a second ago before, also a no op and release. You don't want to have your HTTP logs going out in your release build of your application, right? That's extremely dangerous. So if we're going to build 2 different types of modular or 2 different types of SDK builders, here's the prod builder. It accepts the app context because we want to do some UI work, so that's what we're requiring the client application to inject. But other than that, excuse me, no other debug tooling. And then for our dev builder, we want to inject all this different debug functionality, so we expose public functions on the builder. And then, yeah, they both return the same implementation of the user profile SDK. And like that's the big sell. And what that means is we get awesome debug tools in our development environments, and then we keep our release builds secure. And then all your stakeholders can continue happily using your debug features if they're demoing. Your product owners can do UAT really quickly. Testers, if they're manual testing, can really get some big benefits out of it. And then also automated testing becomes extremely easy. All right, so that's nice to know about different types of SDK builders, but what does it really mean for how do you implement that? So we'll take a second look at this demo app, the user profile SDK, and then hello, I think I called it, hello, my name is. All right, so if you watched yesterday, Sam Edwards' DIY dependency injection talk, this is following the same framework-less approach because it's the no magic kind and everyone will follow along easily. What it does is it's scoping the SDK instance to our main application class, and then it's accessible through any of the activities or fragments or whatever. Also, the product flavors for debug and release, that's how we're switching the builder dependencies. All right, so this is, before we get into the object graphs, this is just a simple injection of the SDK into our demo app. The one thing to note here is that the builder that we're using here is not defined as our dev builder or our prod builder. So this is where we would run into issues because the demo app is not really specifying whether it's debug or release. So launching the SDK becomes, at this point it's simple, right? Because we haven't, the one SDK that we built doesn't know if it's the prod or the debug builder. So we'll go into a minute about how we switch that, but yeah, here's how we would start the SDK. It's just a simple main activity, and the SDK starts the flow, and then the callback is just printing the result to the log when it returns. Okay, so let's separate our dev builder and our prod builder. We'll do it in the application build.gradle using a product flavor, and we're just going to call that flavor dimension configurable. And these are the flavors that we're going to use, dev, mock, and prod. Pretty simple. They each rely on the dimension configurable, and then from there, we've now expanded all of our build variants, and we can start adding our dependencies. You'll see that any of our dev dependencies take the dev builder implementation, and prod builder is included in our prod flavor, and then all the other common dependencies are in the rest of that dependency block. So let's look at an object graph similar to Sam's DIY DI talk yesterday. It's going to take a base URL, OKHTT builder, and an implementation of the user profile SDK. These, all of our flavors will have different object graphs, and each one will implement the SDK in a different way. So for this case, the mock flavor is dependent on the base URL, and then the OKHTT builder, because we want to inspect the network logs as we're using the app, or the demo app. And then it returns the user profile SDK, which is, depending on what flavor we're in, will have the same implementation with different functionality. I'm now realizing I had too much highlighting. Okay, here's an implementation of that same graph. And now we can see that the base URL is pointed at localhost, and OKHTTP builder is really just adding an interceptor for Chuck on it, and then also returning a user profile SDK implementation with our dev builder. Simple. Let's see, this is also just a simple create function on the builder that I used. Not worth a slide. Okay, here's the prod version of that same object graph, except when it's implemented, it's using the prod SDK builder and not the dev builder, still returning the same implementation. Okay, one of the ways this is really neat is that it's utilizing a Kotlin language function or Kotlin language feature extension function. This is it's kind of verbose, but what it's really doing is returning a version of that object graph via an extension function on main application, which I've called onCreateConfigurable flavor dimension. It could be shortened. Now, if we look at the source structure of all of our flavors, you can see that each one of our product flavors has its own graph object, and then also a configurable dimension, which is just this extension function that you can override to inject different features. So if we look now at the main application class, now we have a configurable graph, which each product flavor has, and the extension function returns a version of that configurable graph relative to its product flavor, which becomes really neat when you start, building different types of versions of your app. And like we did before, except when the SDK was scoped to the main application instance, now it's the object graph, and that graph has a reference to the user profile SDK depending on what build variant you're in. And then the callback does the same thing. It's just printing the result to the screen. There we go. So let's take a look at a mock flavor example. Here is 3 build variants on the home screen, launching mock. This button click starts the SDK. It returns my profile. If we look at the network interactions, we see that it's pointing to localhost, so it's on the phone, and I have specified that it returned 200 and just my own profile information. So every time, if I wrote a simple UI test, I could test the happy path really quickly and have reproducible results. And also, if I'm in a bad network connection area, I can quickly demo the app and show everything that I want to show. But maybe we also want to show all of the different other flavors that we have possible. So in this case, on the left, I have prod flavor. And then as we move right, there's more debug functionality injected into the app. So like the dev flavors is still hitting a live environment, but we've added this functionality to do network inspection, and then again, the mock flavor on the right. All right, let's review what we just talked about. An approach to injecting debug functionality into your application in order to separate debug and release code for SDKs is a bit different from how you would do it with an application. So a better approach is debuggable code switches that depend on build configs is to leverage modular SDK builders. And you want to make sure that the dev builder is not published to prod as an artifact, published at all. You just want to publish the prod artifacts. And the real benefit you get here is that you've securely separated your debug and testing code, and nothing that you're releasing in the release production build of your SDK is included with testing code. And then this is like the big selling point. All of your product owners, stakeholders, QA, other developers, backend API engineers, whatever, they all get to use your debug tooling that you've built into the SDK in your safe development environments, and then when it's out in the wild, all of that stuff is kept secure. Let's see. And then that's the end. Thanks.
Are you going to have a blog post on this?
Yes, I actually already have one. It's very similar, and I'll link to it on Twitter also with the slides. All right, thanks everybody.